Now that we have a good idea on how to handle negative exponents and zero exponents, it's time to look at the multiplicative properties of exponents. So now we're going to be multiplying powers. So my first example here is 5 to the third times 5 to the second. And what I want to do is I want to expand this out so that you understand where the rules are coming from, okay? So we're gonna break this thing. We're gonna stretch this thing way out. 5 to the third means 5 times 5 times 5, okay? Times 5 to the second means 5 times 5. Well, what you notice is that everything is in multiplication. You've got 3 5s in multiplication for the first term, and you've got 5 to the second for the second one, okay? Well, what you want to notice is that now we have 5 5s. So I could replace 5 to the third times 5 to the second with 5 to the fifth, all right? Now, there's another way to look at this, and that is just to simply say, well, that's 5 to the third times 5 to the second equals 5 to the 3 plus 2. We just added the exponents. You still get 5 to the second. 5 to the second, 5 to the fifth, okay? So it's the same thing. You can either stretch it out and see it visually that way, or you can understand what's going on and simply know you're going to add the exponents to get the final exponent. Well, let's take a look at another one. Now, the reason you want to understand this and be able to just add exponents, understand what it's doing though, is what if you had something like this? 4 to the 19th times 4 to the 28th. Well, you could start multiplying all those 4's out. 4 times 4 times 4 times dot 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 times 4. And you could lay out 19 4's. And then you could go times 4 times 4 times dot 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 times 4. And then you could lay out another 28 4's. But that's going to take forever. You want to understand that it's so much easier just to think this as 4 to the 19th plus the 28th. You don't have to write out all those 4's if you understand. And you get 4 to the 47th. So you would have written 47 4's. That seems time-consuming and laborious. So it takes us to our first rule of multiplication. We're going to call this rule number 1. How clever. All right? And that says a number to the m power times that same number to the n power. So notice they have the same base, a, and the exponents are m and n. All you have to do is add the exponents, okay? Now, remember, must have same base, okay? So you're going to have a number of rules. So if you want to start making flashcards, this is rule number 1. And now let's take a look at some examples using that rule. So we have example Pocahontas. Okay, so this is 2x in parentheses to the third power. Well, one way to look at this is to say, well, that would be 2x times 2x times 2x, right? That's what 2x to the third means, because the 2 and the x are in parentheses and the 3's outside. Well, we can break that up even more and say, well, isn't that just 2 times x times 2 times x times 2 times x? And then take advantage of the commutative property of multiplication. And we can put all the 2's next to each other and all the x's next to each other. And we see that what we end up with is 2 to the third, x to the third, or if you like, 8x to the third, okay? Let's look at example Bell. Now in example Bell, boy, we're jumping. We've got all kinds of stuff going on. But I want you to notice, the only thing happening here is multiplication. That's 2 times x to the third times 7 times x times y to the second times 3 times y to the third. So let's rearrange things. Since everything's multiplication, take advantage of the commutative property of multiplication. We're going to put the numbers together. So we've got 2 times 7 times 3 times. Now we'll put the x terms together. So that's x to the third times x. There is no x over here. And then we'll put the y terms times y to the second times y to the third. Okay, so 2 times 7 times 3 is 42. And now we've got x to the, and x by itself is just 1, so I can make this x to the 3 plus 1, and then y to the 2 plus 3. So my final answer here is 42, x to the 4th, y to the 5th. Let's look at example Tiana and see how we're going to handle this problem. So what we've got here is we've got a little distribution we're going to throw in. So we've got 3x squared on the outside. We're going to distribute it to everything on the inside of the parentheses. Don't forget to draw your arrows so you don't lose track. And what we've got is 3x squared times 5x plus 3x squared times 7. Now we're going to take advantage of the commutative property again. And this is going to be 3 times 5 times x to the second times x. Okay, so I just rearranged the terms, plus 3 times 7 times x to the second. Now I can simplify this first bit right here as 3 times 5 is 15. Then you've got x to the 2 plus 1 plus 3 times 7 is 21 times x to the second. So we've got 15x to the third plus 21x to the second. Now we can't combine these because these are not like terms and they are separated by an addition sign. If this had been a multiplication sign, that would have been different, but because that's plus, we can't combine these, and that is your final answer on that one. Okay, so don't feel like you have to force those together. Okay, you know what like terms are, so that what you understand about like terms still stands. Don't forget that rule. Okay, let's look at another one. So we've got example Fiona. Okay, so now we've got Fiona, and this is a different type of problem. It says write as a power of 2. So we've got this expression. What we want to do is change it so that instead of 4 as a base, we want 2 as a base. Well, 4 to the 5th is 4 times 4 times 4 times 4 times 4. So 4 times itself 5 times. But each 4 is 2 to the second. So that's 2 to the second times 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 2 to the second. And now we have a base of 2. We can rewrite that as 2 to the 2 plus 2 plus 2 plus 2 plus 2, or 2 to the 10th. Okay, so we took it from a power of 4, a base of 4 to a base of 2. Finally, we've got something like this, where instead of numbers being raised to a power, we've got expressions raised to a power. But that's not going to change anything. The base is x plus y. The base here is x plus y. So they have the same base. So I can rewrite that base, x plus y, and add the exponents, 3 plus negative 7. So this becomes x plus y to the negative 4th. Now, you might think you're done, except you got to remember, you can't leave an expression with a negative exponent. Okay? So we're going to drop this from the numerator into the denominator, and our final answer is 1 over x plus y to the positive 4. And now you're done. Okay? So that's our first round of multiplicative properties.